4.8, spiral similarity. So this is where we're getting to similar switch.
Spiral similarity. Oh, Jesus.
Okay, so if a figure is first dilated and then translated, okay, then the final figure and the original figure still have corresponding lines parallel. So the result is simply a dilatation. Okay. More generally, for the same reason, the sum of any two dilatations, so the effect of performing one and then the other, is a dilatation. So keep doing stuff, parallel lines still go to parallel lines, yeah? On the other hand, if a figure is first dilated then rotated, corresponding lines are no longer parallel. Thus, the sum of a dilatation and rotation, other than the identity, is oh, by the way, I should have said in the previous thing was, like a half turn is sort of like a special case of
Rotation.
of the dilatation where you put it to the other side of O, right?
Yeah.
So that was like a half turn. But anyway.
Oh, when you change the sign of the direct lines.
Okay, so if you rotate it and dilate it, if you dilate it and rotate it, it's not a dilatation, okay? But it is still a direct similarity. Okay? Does that make sense? It still preserves similarity, preserving angles in both magnitude and sign. Okay? Alright. The sum of central dilatation and a rotation about the same center is called a dilatative rotation or spiral similarity. So central dilatation and then rotation about the same center. Does that make sense? So you do this thing. Yeah, about O, right? And then you rotate about O. So that's called a spiral similarity. Does that make sense? So do a central dilatation about O, then rotate. So then this is a notation. We have a notation for this now. So this was like one of the things we did we said at the start but never explained. So it's like O is the center. Oh, no. Yeah, O is the center, K is the ratio, and theta is the angle. Okay? Does that make sense? Yeah. So OAB and OA prime B prime are directly similar after the rotation as well. Yeah.
Rotation doesn't change similarity.
Yeah, and the included angles are equal as well. Yeah. Okay. Since any spiral similarity is completely determined by its center and ratio, the rotation angle, then the notation is OK theta. Yeah. Kind of like function notation. As usual, a rotation in a counterclockwise direction will be positive, rotation in a clockwise direction negative. In particular, OK 0 degrees and OK 180 degrees are dilatations of the types illustrated previously. Yes. Yeah, so this is the diagram for similar switch. Okay? But they don't actually say anything about it. So if you do the same ratio K and then you do yeah, obviously if you let K equals 1, it's just a rotation, right?
Wait, is there a difference between rotating first and after?
Nah, not really.
That's a good question, yeah.
So, in other words, are the two functions...
Can we answer it? So he said if you rotate it first, and then you do the central dilation.
No.
one again, live on connected one of its symbols.
Yeah, so I guess like relative to like the middle circle, right? The image has to be on like some other circle. So once you rotate it and then you do it, it'll still be there. If you do it first, it'll be there and then you rotate. Yeah. So it's basically those two circles. Yeah, and if it made a difference, this definition would be different. Okay, so here's the spiral. So here's the similar switch diagram, which I don't think they say anything about, do they? I don't know. So you have a triangle like this. Yeah? So this is A prime, B prime. And that's AB. Yeah. This is O. That makes sense. So this is the this is the diagram. So there's like two pairs of similar triangles. Two pairs.
So first OA, B, O, A prime, B prime. Second was O, A prime, O, B, B prime.
So it's like this and this, yeah?
So this is this of the switch.
And then also the tiny one. Tiny that triangle at the top.
B
Oh,
prime,
B,
A
A,
prime, and then
X.
whatever X or something.
oh yeah,
B and
that's
prime.
70 also some.
That's also similar.
Which one?
A prime, B prime, and then whatever the other
The
one.
intersection of A prime and B prime. Call it X.
X, and then the other side, call it Y.
Wait, why are they similar?
Actually, yeah, why is similar? Oh wait,
They are.
yeah, they are. They actually are. Because you have vertically opposite angles.
And
A
then
prime.
A prime, O, A prime, B. It's the same as O, B prime, A, right? So that angle is shared. So we have two equal angles.
Yeah.
So that's it.
Wait,
Two
where's
equal
the,
angles, so they're similar.
you're saying this triangle here?
No.
Which triangle are you saying?
The smaller one.
This one. This one.
Yes. That last point.
This one.
Call that Y. And the one on the opposite side.
Yeah.
Yeah.
Something else.
X. And doesn't matter.
Y prime.
Call it
Y prime.
lambda.
Yeah, Y prime.
Lambda.
Why lambda? Why me?
Oh, you're saying those triangles are similar.
Yeah.
Why? So you're saying that the intersection of A prime, so it's saying like this triangle is similar to this triangle.
Oh,
I don't think so.
I'm not sure about that.
Actually, no.
That's
Nah.
not similar. Not similar.
Yeah, at least we get
Right.
one pair of cyclic ones. We get one pair of cyclic ones. So that's pretty irrelevant.
Pretty good.
Yeah, if you join O and the intersection of that, you get a pair of cyclic ones, but that's quite irrelevant.
Not that relevant. Cycle quads are pretty good.
So you get the intersection of A prime and B prime, and you join it to O, and you make a cyclic pair of cyclic ones.
Yeah, because OB prime and OB is K, and OA prime and OA is K. And this.
Yeah, similar switch sets for share angles. That we can find cyclic
Actually, the
ones.
diagram in PST was probably better for this because it has a little cool shaded part.
What does PS2 stand for?
Oh,
Tactics.
no, it's called Petty Shitty textbook.
Oh, okay, it's under the laptop.
Oh,
Petty Shitty textbook. PS2.
Oh, Okay, so
I feel like
Do I smell something good?
Early year.
what is it?
Let's see some epic PST. Yeah, definitely the best.
Wait, you also have it?
oh, okay. So the way they drew
I
it.
got it yesterday, but they're really like this damage.
It showed you that the damage in the bag.
I opened it, I was like, what the F? I was like partially damaged.
You should
It was like this. You have a triangle like this.
Yeah. It is pretty shit.
Oh, pretty shit.
Like a similar triangle like this.
Wait, they can overlap.
They overlap. Look.
Yeah, they can overlap, and they can also not overlap. Sure.
I want to learn that.
You probably can.
Is this
So easily distracted.
the converse?
The same thing that's in that book is in this book.
So it's actually if and only if. Okay. So I'm just trying to draw this.
Yeah, I think so.
Okay. It's saying similarity. Symmetry.
Not symmetry.
Similarity because you're like lengthening and
Oh, yeah.
contracting.
You're
Okay.
dilating.
So not everything is like in school where something is just something you already understand. Yeah. You actually have to learn some stuff.
Why is school always like that, man? Why is it not cool?
Because it's not easy to know something you don't understand already.
School math is, here's the result, just deal with it. That's more like school math. They don't make you do anything.
Okay, so do you understand what I'm trying to say here? So if we label this, so this is from the PST A4. Okay, so this is
I see.
APCBD, yeah? And this is the same APCBD, yeah?
Then APB.
See how that works?
APB similar to
The
C.
B is A and B is C.
Also, these are actually, I know what you're saying. You're saying you're rotating, yeah. 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 For some reason, it's more clear to draw the diagram in different color. Yeah.
So AP on BP, the AP on BP is K, CP on BP is K, and APC is equal to BPB. Yeah, so there's some.
Yeah. So you're saying AP on BP on CP is K, right? Yeah.
AP, no, it's AP on.
Oh, I'm doing this diagram. Okay, you're doing that diagram. Okay, so you're doing that diagram. That's fine. I mean,
Oh, it is.
so then you have AP on BP equals K, right? Which is equal to so in this case it's BP on BP on DP, right? And in this case it's CP on DP, yeah? So they're equivalent, yeah? That makes sense? So these two are similar if and only if those two are similar. Yeah? For the same points. And
Oh, okay.
that's why it's called a similar switch.
You switch up the signal.
So you can see, like, basically the idea is this sort of rotates the vat, right? So therefore the angle of rotation.
Oh, those two have to be
So
equal angles.
this angle has to equal this angle,
Angle,
right?
which means that angle is equal to that angle, which
Yeah.
means they're similar.
Right. That means this angle has to be equal to this angle, right?
Yeah.
And then the sides are in the right ratio.
Oh wait,
That's true.
that's such big thing.
Oh, shit.
Yeah, that's right.
You know that the two diagrams are actually the same diagram.
Yeah, and the same diagram. Just they
But
have
why would they
triangles.
draw? But why would they draw it separate?
What?
They're saying that the both are basically the same diagram.
Yeah.
Yeah, but why would they draw separate?
To make it clearer.
But this one's got a cool color coding to it. This one, for some reason, the color didn't help.
The color code is kind of weird.
Oh, because you need like two different triangles.
Yeah. So here it's like
The top one
the
actually
green
makes
is
sense.
similar to the red. Yeah. The green is similar to red. Yeah. Here it's green is similar to green and red is similar to red.
Yeah, which is kind of.
APC.
That's why the coloring didn't work.
Yeah.
Wait, but that's not even APC.
So this, I guess this, what we're doing here explains this, because you could just prove it as well, right? But this explains it in terms of geometric transformation, yeah? It explains it in terms of a spiral
Feels like
similarity.
that is
Yeah, it is.
Okay, sure, but
Okay.
what time is it? It's time to learn.
12:30, huh, way up.
not really.
Wow, legit the only color they use is blue.
Okay, so,
And also black and white.
And red.
No,
actually, I think you could probably understand this even better if you could
Oh, yeah,
somehow
you could
get rid of that.
So cross multiply. Yeah, so you actually AP times DP times D. Yeah,
So,
and you can just move.
So AP times BP is equal to CP times DP.
And it doesn't matter which diagram you use, it's still the same.
So, cyclist one.
Look, it doesn't matter what you use, what diagram you use, the result is still the same. Whether you use AP or the CP or AP or the BP.
Yeah, I mean, yeah, like, I was wondering if you could see it even without writing down any algebra. Because it was nice to see the rotation, right? Should it be intuitive that it would? So that rotates to that, so that's obviously similar. I guess it's not that obvious with this length, right? So you kind of have to switch triangles. Okay, so they say let us use spiral similarities to prove this theorem. Okay. So we all got what this is, yeah?
Makes a lot of sense.
Okay, so you got squares with centers O1, O2, and O3 are erected externally on the sides of a triangle.
Right,
So you have a
is that the
triangle
same-
ABC, yeah?
Is that the same problem? It looks like the same problem.
Huh, so what's in the four except that is three squares. This is a Pythagoras proof.
What?
Oh. How'd you know?
Prove that it's a right angle
It's not a right angle triangle.
if the areas add up.
What do you mean the areas add up?
That
Well,
proof is, that's a Pythagoras square proof.
Okay, so
Yeah.
then the line segments O1 and O2 are equal and perpendicular. So hold on. So if this is ABC, yeah.
some three fixed squares.
O1,
Squares.
O2, and O3. Yeah? Then the conclusion is the line segments O1, O2, and CO3.
O1, O2, and CO3 are perpendicular.
O1, O2, and CO3. How do you know they're perpendicular there?
No, we're supposed to prove that.
So we're saying they're equal and perpendicular.
Equal, the lines are equal.
So this is another complex batch thing that you could do. But yeah, I should have done the other one earlier.
No complex
No
batch.
complex
Oh, yeah.
bashing. I don't understand
No,
that.
complex batch bad.
Geometry good dash bad.
Does that involve similar switch? It appears so. Actually, it's like it does not.
But can you say
Wait,
that?
what's the draw
The
triangle
middle
one?
point is in ratio with.
But it does involve similar switch.
It actually does, actually.
If it's in relationship with the
You draw the diagonals of the squares.
Yeah, that's
and
what I was
then-
thinking. That's what I was thinking.
Yeah, that was what I was also thinking.
And then you
Oh,
can
yes.
include the middle triangle and not include the middle triangle below because the outside is in the inside is also similar. And you can do that for all three sides.
Could you explain it?
Yeah, it's how we got this.
You know,
I'm not sure, but
So you're
I'm
saying this diagonal?
drawing the diagonals in.
what did I have in
This one?
Oh, so like you get the similar switch because you know the outside are similar, right? So
Yeah.
the triangles. So the inside, including the inside triangle, must also be similar.
Yep, so which triangle is that?
Not all the CA. So the one with the diagonal triangle is similar to the diagonal triangle.
Yeah, so maybe in our good diagram you're saying it's like this one, right?
Yeah.
And then you have this one.
And then you similar switch it, including the middle triangle. Oh wait, that's just because of diagram dependency. Never mind. I thought that was
That's how you
actually
solve problems.
I think you can use O2O1 as a similar triangle, like that one and that one are similar.
Right, so long as no, not below.
Equal and perpendicular.
C, B, and whatever that point is similar to CA, whatever that point is.
Yeah, so I guess we can try and rotate, yeah?
What about reflect? We don't have to.
Yeah, there's a couple of these triangles around. So we've got to pick the right one. Did she say food was ready?
Huh? No.
She didn't come in and say food was ready.
Like, no, but like, okay.
Yeah, let's both try.
Taste testing.
Yeah, taste test it. Hey Z, do you want to go to the bathroom? What do you need for your
It's still boiling.
Oh, okay. Alright, let's go to lunch.
Yeah, because I can't.
Z,